Again, we haven't seen anything bypass App Store on Apple, but let's take Symbian Sign, which is similar in many ways. I mean, if you want to have your application running on Symbian devices, you have to submit it for testing, and it's tested. If it requires deep rights like, accessing the internet, accessing your private files, it has to be actually checked by a human being and Symbian. Simple stuff gets automated testing. And that has been bypassed. Plexify, in particular, bypassed it with a mechanism where they submitted a program for certification, and the program looked like a completely different application. It didn't look like Spy 2, it looked like a backup software. That's the user interface for backup software. When you install it, it takes backups. But then when you actually install it, buy the tool, and install it to somebody else's phone, again, it looks like a backup software, but there's a hidden interface which changes the software to a spying tool. And then you can hide the old software. So what they signed, what they thought they were approving, was a backup software, which requires access rights to every of their system. And what they actually signed was a spying tool. And the same thing could be done against any similar mechanism or any similar whitelisting system like App Store.
There's also a sort of subtle problem with, I prefer the terms allow listing and block listing, because it's had a problem with saying whitelisting and blacklisting. It seems kind of sort of rather racist and old-fashioned, isn't clear what it means. The problem with saying this program is definitely no good is that sometimes even experts can make mistakes for considerable periods of time, which then gives a kind of ultra blessing, which makes it really hard to convince people that that decision is wrong. And you also do have the potential problem that in order to determine is that whether the mechanism by which you determine the thing that you're about to run is genuinely the object of the thing you're running. That depends on the security of the potentially fragile underlying device. But I think most of us in the anti-malware industry these days would rely on a variety of techniques. That there are files that we're all collectively, through sharing information, pretty damn sure are not particularly harmful to your system, like any of the many well-known Microsoft system DLLs. There are files which we know are outright bad, like the Sony rootkit, because it just comes with these terrible security risks. But there's still that sort of grey area. And the other problem is that a lot of people go, we'll work out all the applications we use in our business or we use on our mobile phones, and we'll kind of log those and we'll restrict ourselves to those. You then enter a world which is surprisingly inflexible. And another issue that allows us is it absolutely doesn't deal with stuff that's sort of generated on the fly inside your browser, for example. So there are always going to be holes in that. And I think in that approach,
I agree with what Paul is saying. I mean, whitelisting has absolutely its space as part of the solution. However, there are solutions which claim to fix everything by just whitelisting the stuff you want to use and disallowing everything else. The problem there is, yes, you might be able to pull that off for applications. But then when you start to think about exploits, how are you going to whitelist the PDF files you want to use in your organization, or the Word doc files you want, or the JPEG files you want to use in your organization? Obviously, you can't do that because people are modifying doc files all the time, and some of the doc files out there are malicious. So whitelisting can't work with document files, and yet they are malicious document files. So it will fall short as its solution by itself. As part of the solution, it works.
You guys, I think, tried it years ago, didn't you, in the days of word macroviruses, having a tool that allowed you to bless the macros you wanted to use inside your organization, and then you block everything else, you kind of be immune to what was then massive macrovirus problem. And it sort of didn't work because people underestimated the extent to which their environment was changing, and it kind of became disruptive to their business. So it sort of became seen as a problem child rather than anything else.
Just I'm taking notes, and I figured they were sort of blocking them out. The key thing I think to keep in mind is any sort of allowed clone service. So I think the promise is you want to attract space and that kind of thing. The key thing I think to keep in mind is any sort of these software blessing, whatever mechanism it is, whether it's a hash or code pages or whatever, do your needs align with those who's gating in this case the App Store? And the answer is, in the case of Apple, probably not, unless you're a direct revenue stream out of Apple and work there or something like that. I think that's going to be a problem that magnifies in this space, right? So as long as Apple is making money, they don't really care what you run until it potentially impacts you leaving the platform and costing them. Now, that said, I anticipate in the next 3 to 5 years, providers doing another layer, carriers doing another layer of App Store checking to protect their own networks. So the biggest motivation for Apple is to make a bunch of money, to make a traffic platform make a bunch of money. The biggest motivation for carriers in screening out potentially unwanted applications is, of course, to keep customers and keep data. And you do that in a couple of different ways. One is if you know that if you're on some carrier X, they always have lots of problems with their devices. Carrier Y is not. Let's use carrier Y because they protect their customers. But also, when they protect their networks, they have better network service. They're going to say, oh, my call's going to adopt the carrier Y. And then on carrier X, they always have the packet service. So that's, I think, where that ability is they're going to want that ability to start getting. And I think that that's going to be much closer aligned to what customers want if it's structured and it was routed more closely aligned to what your interests are as an endpoint, securing your device, securing information, etc. So I think that there are mechanics we can employ around this, whether it be like a file hashes, code pages, whatever, system calls, and ways you access data. There's also things you can do. It's what we're trying right now, but what we have right now is something disconnected from true security.
I think there's a hidden part to that. If you look at Microsoft's digital code signing model with and the idea of certificate revocation, this online lookups to see which certificates have been retired, we've got this amazing mechanism which should work really well. But I believe one of our guys in Canadian lab discovered when they're investigating what happened when the certificates stolen for the Stuxnet malware were retired. They were merely retired, but it didn't retrospect the design of the system just to prevent anything going wrong, maybe the system won't boot properly. It doesn't retrospectively retire anything. It just retires it from that time forward. So anyone who's already infected is pre-shafted, if you will. And so, in other words, wherever I hear an hour listing, or wherever you think of and combined with an App Store blessing, I just get a little reek of the words public key infrastructure. And we've been spectacularly bad at doing that as collectively as an IT industry.
Chris, I think you're familiar with him. For those of you who aren't, a guy, a friend of mine, John Oberheim, has done some really cool work at analyzing and stuff through the App Store models. Another person has done some really cool work, I forget their name. They have a proof of concept where their software behaves properly within the App Store checking process, or behaves properly, with quotes, and behaves as they intended, which is to say maliciously, on a real device. And they just do some simple environment checks and activate certain kind of code portions. It's truly bypassable, which is why you and I were talking before the panel about some of this stuff. I was curious what you would do about what you're doing. I think that there's ways around it. So like I said, just depends on technology.
Thank you. The people are question on the left below.
Yeah, this question is regarding usability versus security. Like given the millions of devices used by a lot of users, maybe considering the emerging market scenario where people are not so literate. Now the cloud computing is coming up, but we have a lot of private data that people already want to go online nowadays. So what are the challenges in terms of still keeping the application secure but still keeping the usability as a key criteria to sell the products? So what are the challenges and whether the existing architecture is sufficient to help out, or maybe we have to re-architect the whole thing in the client versus the cloud to make sure that the system is robust? So from a security standpoint, what are your thoughts?
Well, I think it's really all the thing, like usability versus security. So
pick any 0 of 2.
Yeah. So if we talk about like different mobile platforms, some of the vendors they found this, I think, some kind of balance between usability and security. For example, Apple iPhone. It's really usable. It's for many people, it's really comfortable to use it, and it's still this Apple Store model for like only accepted software, only checked software can be installed on the smartphones. It's working because we still there's iPhone was in 2007. Yeah. So for 3 years, we haven't seen any kind of Apple Store malware still. So it means that Apple almost they found some kind of a balance between usability